Okay, continuing on with our Laplace transform playlist, we have something kind of following up on the previous video where we solved an integral with the Laplace transform. Here we're going to do it again. We have a slightly different problem. The real key is this lower bound. So what we're going to do is we're going to look at the integral from 3 to infinity of cosine 4t e to the minus 2t dt. Now the reason why I say this one's different is because to do a Laplace transform the way we had it set up last time, this was 0. So now we don't have our bounds quite set up the way we want. Now again, we could still do this with integration by parts and that would be fine, maybe easier, I'm not sure. But I still want to handle this one with Laplace transforms. So what I can do for this set is just try to shift the bounds. If I can get my lower bound to 0, then maybe we can use Laplace transform. So we'll just do a u substitution on this. I'll adjust my t by 3, so we'll say t minus 3 will be our u value. Solving for t, we say t is u plus 3. Then I'm just going to go ahead and take a derivative on this thing, right? So derivative here, this dt value is going to be, derivative of u is going to be just du. So now we'll just go ahead and I'll do this substitution. So plugging in infinity, where's my infinity? Okay, so we'll plug infinity in here. Infinity minus 3 is still infinity. Now we'll plug our 3 in here. 3 minus 3, this gives me the 0 that we need. And so that's exactly what we wanted. Now going on cosine 4, now plugging in for t, we want to plug in here. We want to plug in u plus 3 here. And then doing the same thing over here on e to the minus t, we plug in u plus 3 du. Next, what I can do is just kind of expand, multiply everything out and rewrite this. So doing that, let's see, this is going to become, this here will become cosine 4u plus 12. And then here, this is going to become e to the minus 2u, distributing minus 2 times plus 3, that's going to give me minus 6. But what I really want to do with this minus 6 is break it off separately. So addition and subtraction we can write as multiplication in the exponent. So I can write this as e to the minus 6 here. But now this is just a constant value. So let's bring it outside, we'll bring it out front of the integral and make it go away that way. But now just notice we have this thing exactly in the form of a Laplace transform. We've got our bound to 0 to infinity now. The s value in this, we're just going to have s equal to 2 in this. Don't worry that the variable is u, right? We could turn it back to t if we wanted for a definite integral, but the variable name doesn't matter, so this is still going to be a Laplace transform. So what I can do is, coming over here, just noting, again, our s is going to be 2, and keeping this e to the minus 6, we can write this as e to the minus 6 times the Laplace transform of this thing, which is just cosine 4u plus 12. I could change it back to t, but again, it doesn't matter, so we'll just write it like this. But now for a Laplace transform of this form, we have a formula for this. We did this quite a few videos back. It's kind of a complicated formula and hard to remember, so let's just write it down and recall this formula. Okay, so we have our formula over here that we can use, and just notice the denominator is like exactly the same as when you just have like cosine of at. That part didn't change, but the numerator is kind of complicated. So going over to our problem, so our a value right here, our a value is going to be just 4, and our b value in this is going to be 12. So all we're going to need to do is just kind of come back here and plug everything in. And I will actually plug in the s value right now too. So doing this, we'll copy down our e to the minus 6 in front. And then for this, we'll have s, which is 2, in the numerator. Then we're going to have cosine of b, which is 12, minus a, which is 4, times sine of 12. So this is all going to be, and this is all going to be over s squared. So we're going to have 2 squared plus a squared. So it's going to be 4 squared. And then let's just simplify this thing. So in the denominator, we'll write it under a big denominator like this. So this is going to be 4 plus 16. So our denominator is going to be 20. And I think I'll just write the e to the minus 6 on the end. We'll just copy down the numerator, 2 cosine 12 minus 4 sine 12. Maybe I should reduce a little bit. Like I can cancel 2 with 20 and get 10 here, but then I need to change this to a 2. So for my final solution, we'll just have cosine 12 minus 2 sine 12. I can actually bring this into the denominator and write this as 10 e to the 6, and that's how I can squeeze it in there. Okay, so there you have it, solving another integral with Laplace transforms. Thanks everyone for watching today. Have a great day.